Hello everyone. What you see on the screen, there are 150 particles because I have counted it here. 150 particles floating and connected to each other, forming a living constellation like a structure. When I move the mouse across the canvas, the particles near the cursor flee. You can see, but here it has its own position and velocity. Every connection is drawn live, with the 60 frames per second, and based on how close two particles are to each other. The mouse repulsion is just a distance math, no libraries and no plugins. This is the most visually impressive thing I've built so far, we've built so far in the series, and it is also one of the most practical thing. This is the exact pattern runs on portfolio sites, agency home pages, and landing pages all over the web. You may have seen this kinds of animation, canvas animation in internet. There are chances. So that is what we are going to do. Welcome to Scratch Start, and today we are going to build an interactive particle constellation. This is the initial state browser output without any necessary JavaScript input. So let's start directly with the JavaScript part. So I haven't wrote the program from the start, creating the identifier variables using identifiers, creating the canvas and everything. So this is the standard code, the canvas size we have written in so many videos in the previous videos, so we don't need this. And these are the global variables. I have created the particles array and the total connection. This is one of the new things. It is I have assumed it to 0, and the animation ID is passed. You know about these things. And this section is another important thing. In the browser, when we move the mouse towards the canvas, that means inside the canvas box, that means go to the browser, you can see in the browser outside the canvas box you can see the mouse, but inside, see, it is disappearing. That is what we are going, where we have to write the logic. It should work correctly, right? So go to the code editor. When the canvas is moving, that in the event, that is inside the canvas, I am writing the logic now. When this is happening, I am creating a new variable called rect, and it selects the canvas size, get bounding client rect, and then we have to give this the x that is the x coordinate and the y coordinate. Mouse's x coordinate is events client x minus rect left, so that we can calculate the horizontal position. Then we have the mouse's y coordinate. For this, the same thing but on y axis, event client y minus rect top. Next, we have to return make it the mouse is active or not. Is the mouse active? Yes, it is true. That is, when the mouse is inside the canvas, it is active, so it will disappear. And we have to change the mouse status. That is just a text content. Here you can see the mouse status. This is, we have to update this. So the mouse status, change the text content to active. So that's all. Now one section is finished, and then now we have to write the logic if the mouse is not in the canvas. So for that, I am using the mouse leave event, and I have to change the mouse's active state to false. false, and then I have to change the mouse status. Mouse status values text content to waiting. So this is finished. Next we have to give the input for the colors. So I have created the colors array, and this is a creation of the particles. I have explained how it is done in the previous video. If you want, you can check out from there. And then the particle is created, and then the next important thing, this is the main function that is going to happen: the particle field creation, the particle updation, drawing the connections between the particles, and drawing the particles. These are the next important things. This is the main thing we have to write. So let's write that. So initial particle field, I have created the create particle field function. Inside that I am selecting the particles array and changing its length, assuming its length to 0, and then we have creating a variable called amount and assigning it as 150, and then I am going to use the for loop here to make the function repeat until we reach the limit. Let initial amount I equal to 0, and when I is less than the amount value, and we should increment I by 1, and then we have to include a create particle function, and the particle will get created. Then we have to again call the create particle field function, so the particle will get created, the field will get created, the whole section inside the canvas will get created. Then we have to update the particle. So for that, here we need the total connections variable and assuming it to 0. I am assuming it to 0 because I am writing a common logic. It will happen either when the particles are present, or it is blanking start. So for the safety purposes, I am using the particle length 0 and total connections also 0, and then I am selecting the particles array, and for each of the array element I am executing a function with parameter p, that is the particle. Inside that we have to create separate sections now. Initially we have to do the floating moment. For the floating moment, that is the x1, we have to calculate the x and y coordinates in accordance with the velocity. So I am adding the current particle's x coordinate with the directional velocity, p dot velocity x, and then same way y2, y axis, p dot velocity y. Then the bounce effect. For the bounce effect, I am using if logic because the bouncing happens under condition. If x coordinate is less than or equal to the radius, and if the x coordinate is greater than or equal to canvas's width. This is the x-axis condition. We should make directional velocity in x-axis is multiplied with -1. But now we have to write for the y-axis. So if directional y coordinate is less than or equal to radius and if the y coordinate is greater than or equal to canvas's height, now we have to change the direction of velocity in y direction. P dot velocity y is multiplied with -1. Now next, the mouse interaction, that is the thing I explained before. When the mouse enters the canvas, it should disappear, that is, it should become active. So if the mouse is active, we have to calculate the difference in the positions. The dx value is mouse's x coordinate is subtracted with the particle's x coordinate value, and the difference in y coordinate is calculated with the mouse's y coordinate subtracted with the particle's y coordinate. And then I have set the distance. We have to calculate the distance variable using mat method, mat square root of dx square, that is dx dot dx addition dy dot dy. This is just a basic mathematical formula. You know it, if it is familiar even from the school, so you know it. So I'm not going to explain this section. Next, the next section is I'm going to use another if logic here now. So if the distance is less than mouse's radius and the distance is greater than 0, we have to change the force value. Const force value equal to mouse radius minus distance. Mouse's radius minus distance. That value will be divided by the mouse's radius. And then the px value is updated. It is calculated by subtracting the difference in x coordinate divided by distance. Divided by distance, and it is multiplied with force and multiplied with 2.2. Then we have the y coordinate. It is also the same formula but with the y coordinates. Dy distance multiplied with force and 2.2, and that's all. The whole logic is now finished. Now we have to write the draw connections section. So to draw the connections, I am going to use that is the nested loop here. So since I am going to move the objects, each particle in accordance with the surrounding particles too. So for this is the outer loop. Initial I value is 0 and I is less than the particle's length. Particle is length, and it should be incremented by 1. If that happens, I am going to include another for loop with condition that j equal to initial values I plus 1. And then if j is less than the length of particles array, and j should increment by 1. So now we are going to update the particle 1, particle 2, and dx, dy, and the distance. So I'm going to take a variable called p1. It is calculated using particles arrays I value, that is the initial value, the index value. Const p2 is particles array j index value, that is the surrounding particle j value. Now we have the dx value, that is p1 6 coordinate minus p2 6 coordinate, and then we have dy, that is p1's y coordinate minus p2's y coordinate. Now we calculated the updated dx and dy values. Next we had to calculate the distance value. Using the math square root value method, square root of dx square under dy square, dx star dy, dx plus dy star dy. Next we have to calculate the next part, that is we have to draw the particles now, updated particles. So if distance is less than 120 pixels, then we have to increase the total connections by 1, and then we have to start the drawing, ctx save. So the previous values will be updated, the continuous values, and then we have to assume ctx is global alpha as 1 minus distance by 120, and then we have to begin the path now, ctx begin path, and then we have to write the values where to create the particles. So start with the move to, it is just a point connecting the points. So I am creating move to first value p1x and p1x and p1y. So this is the first coordinate, and then we have from this point we have to draw the line. So line to p2x and p2y. Now we have to give the line width, connecting lines thickness. So line width is equal to 1. Line width is 1. We have to give the color for the line. So stroke style is equal to f value white, and then we have to draw the line, ctx strokes, and restore the previous value to ctx restore. So that's all. Now the whole section is now finished. Now we have to draw the particles. The whole previous section is to connect the drawn particles. Now we have to draw the particles. So I have created draw particles function, and then I am creating a particles array, and for each array element I am writing a function with variable with the parameter p, the particle, and then I am going to begin the path to draw the particles. The particle is a circular thing, so ctx arc, we have to give the values px, py, we should have a radius, the starting point angle 0, and it should end with the values mat pi, that is 2 pi r value, and then we have to add the stylings. Ctx fill style is equal to p dot color, that is the particle's own color, existing color. Then ctr, we should have the shadow color, it is same as the particle's color. And then the ctx will also have a shadow blur too, shadow blur is equal to 15 intensity, and then we can fill the values. Now the next functions are already written. We have updated the UI, we have cleared the frame for the next functions, and to create the animation loop I have included all the functions and request animation frame, and I have wrote the button functionalities for the play, pause and reset buttons. And to start the animation I have included called the update UI under animate function too. So now the whole thing will work. Let's go to the browser. So there is some kind of error, and let me fix it first. All the codes are now fixed, it is just a regular syntax. Let's reload. See, the particles are there. When I move inside the canvas, the mouse disappears, and when I move the mouse near the particles, you can see some kind of distortion happening. It is very minute, but it is happening. I don't know if you can see that on the video. You follow the mouse and you will understand. I am moving the particle, green particle in the top side, and it is moving, and I am moving the cluster now, so it is scattering now. See, it is scattering. So that is how it operates. And see, here the particles are getting updated in the real time, and the connections are also getting updated in real time. And the mouse status, see, it is outside, so the mouse active class is not true, it is false, so it is still waiting status. And when I move inside, see, it is active, so it is also working. And when I click pause, the connections are paused, and when I click reset, everything gets resetted. When I click play, it is playing. So that is what happening. Each colors will be selected in a random manner, so the colors will change each time. Reset, see, that is what we done today. So this is most very really hard for me to calculate and do things. So yeah, that is it for today. Please do like the video and share the video if you like it, and please do comment about what you think about this content, and also what to do next, and what kind of content would interest you. And yeah, and I will meet you guys in the next session with another different video. Thank you.